In late March, at the Ignition Conference, the agency under new administrator Jared Isaacman unveiled what may be the most packed news package in years. When it comes to the moon, they're not thinking small. The Gateway Lunar Orbital Station has been put on ice for now, and all resources are being thrown behind a full-scale surface base instead. Pouring billions into a staging post in lunar orbit right now simply didn't make sense. Every resource and every ounce of attention is shifting to the lunar surface itself, and that's where the real contractor brawl begins. NASA has two contracted lunar landers, SpaceX's Starship HLS and Blue Origin's Blue Moon. The agency is laying down a hard condition. Whichever of them first proves its safety in an orbital demonstration mission in 2027 gets priority rights to deliver astronauts to the lunar surface in 2028. That said, Bezos' operation won't be left without work regardless. Their subsidiary, Honeybee Robotics, just landed a major new contract. They'll be delivering scientific equipment and hardware to the lunar South Pole, laying the groundwork for a future human base. Nuclear tug, lunar base, and a swarm of Mars helicopters. So what's the plan for the lunar base itself? Construction is broken into 3 phases. Phase 1 involves 25 launches. Yes, you heard that right, 25 launches, of which 21 are surface deliveries in the form of uncrewed landers, and the remaining 4 are orbital relay satellites. The headline edition will be what NASA is calling lunar hopper drones, otherwise known as the Moonfall Project. Instead of slowly crawling across craters, these vehicles will travel by hopping. Each hop lasts 2.5 minutes, reaching about 1 kilometer in altitude, and a single hopper can cover up to 50 kilometers in total. To survive the lunar night without freezing, they'll be equipped with radioisotope power sources. Phase 2 kicks off in 2029, with another 27 launches and 60 metric tons of hardware on the surface. The agency will begin delivering heavy infrastructure, pressurized crewed rovers, telecommunications towers, and vertical solar arrays rated at 10 kilowatts each. And Phase 3, slated for 2033 through 2036, is the stuff of science fiction. Nearly 30 missions will deliver a combined 150 metric tons of cargo to the moon. That includes fully pressurized habitation modules, in-situ resource utilization equipment, and actual nuclear reactors to power the entire base continuously. On top of that, dedicated return modules will be capable of sending half a ton of extracted materials back to Earth per trip. On top of all that, NASA is getting serious about finding lunar ice and developing rovers. The Viper rover project, which had been in limbo for a while, has officially been handed over to Blue Origin and will be sent to the South Pole in late 2027. NASA has also issued tough requirements for future crewed lunar rovers, a minimum range of 900 kilometers. But the boldest announcement was saved for deep space. NASA officially announced the development of the first interplanetary nuclear electric propulsion tug, Space Reactor 1 Freedom. And there's a rather elegant piece of engineering at the heart of it. Remember how the Gateway Lunar Orbital Station was put on hold? Well, its key module isn't going to waste. It's being repurposed right here. Jared Isaacman confirmed that the completed power and propulsion element, or PPE, originally built for Gateway, will be put to work. It will serve as the backbone of a powerful 25 kilowatt Mars nuclear drive system with electrostatic thrusters. As it approaches Mars, the nuclear tug will release an entire squadron of next-generation research helicopters, successors to the legendary Ingenuity. In fact, just recently, on April 19th, we marked the 5th anniversary of Ingenuity's first flight. 3 rotorcraft will survey the terrain, search for subsurface ice, and scout out ideal landing sites for future human missions. That's the Skyfall project. Following the Mars tug, NASA plans to launch its first nuclear reactor for the lunar base as well, in 2030. Let's also not forget that the Dragonfly mission is scheduled to launch in July 2028, with arrival at Titan expected 6 years later, in the second half of 2034. It really does seem like the arrival of Jared Isaacman, billionaire, spaceflight participant, and commander of the commercial Polaris missions, has given the agency a serious shakeup. There's a new smell in the air. Pragmatism. Less bureaucracy, more private sector involvement, cheaper, faster, and results-driven. We'll see whether he can keep up this blistering pace. Will Starship replace SLS? A natural question. The crew just flew around the moon. So what comes next? What comes next is a fundamental restructuring of the Artemis program. NASA has officially overhauled the program's architecture. Shortly before the ignition presentation, Bloomberg reported that Boeing's eye-wateringly expensive SLS rocket would be stripped of its primary role, with the lunar transportation job handed entirely to Starship. The idea being that SLS would simply lift the Orion capsule to low Earth orbit, where it would dock with the SpaceX lander, which would then haul the whole stack to the moon. Reality turned out to be a bit more nuanced, but those reports didn't come out of thin air. According to official NASA documents, Artemis 3 is no longer a lunar landing. In 2027, it will be a purely demonstrational flight to low Earth orbit. Orion will dock with commercial landers, astronauts will check out spacesuits, test the life support system, and come home. As for scrapping SLS entirely, it's too early to write the rocket's obituary, of course. The agency's stated position is that it should fly the first 5 missions, but NASA has already started trimming costs. The agency officially canceled development of the new Exploration Upper Stage, or EUS, for SLS. A second stage that Boeing had been working on for over a decade, and on which more than $3 billion had already been spent. Instead, NASA is switching to the standardized Centaur 5 upper stage from ULA's Vulcan rocket, a proven and cheaper solution. But here's where it gets really interesting. In the latest NASA budget documents, the agency states plainly, after the 5th mission, plans to retire the costly SLS and Orion stack. After that, astronauts will fly on commercial vehicles. Congressional politicians may not be thrilled about these plans, but NASA is sending a clear message. Flying to the moon needs to be fast and affordable, and betting on slow-moving legacy contractors is no longer the plan. We wish them luck. The future built on ISS. On March 24th, at the Ignition Conference, NASA presented not only sweeping changes to the lunar program and the nuclear Mars tug, they also unveiled a reworked plan for the future of orbital stations. The agency acknowledged something important. Commercial players like Blue Origin or VAST won't be ready to replace the ISS on their own. They lack the experience and the budget. So instead of waiting, NASA is now going to commission its own government-built hub module. The plan? Launch it to the ISS in 2029, dock commercial modules to it, and then, ahead of the station's deorbit in 2032, undock the entire commercial segment and set it free as a standalone outpost. NASA plans to allocate $250 million per year toward the module's development. That way, the agency handles the hardest systems itself: life support, propulsion, and power. The official request for proposals opened on March 25th, with final project requirements to be locked in by June. This approach is designed to maintain a continuous U.S. presence in orbit without any gap after the ISS is retired. Staying on the topic of the ISS, Roscosmos is planning a similar undocking maneuver of its own. In April, at the Team of the Future Forum, Vladimir Kozhevnikov, chief designer of the Russian orbital station, shared fresh details on the ROS project. The new station is now proposed to be built not from scratch, but based on the Russian segment of the ISS. As a result, rather than the previously discussed polar orbit, the new station will fly at the same inclination as the ISS, 51.6 degrees. This reduces radiation exposure, keeps the station permanently crewed, and gains up to 20% in launch mass efficiency. With the orbital change, the first modules will launch from Baikonur rather than Vostochny, and they'll be serviced by an upgraded Soyuz ROS spacecraft rather than the Oral vehicle, though Oral hasn't officially been canceled yet, despite its notoriously drawn-out 17-year development timeline. The first module to go up in 2028 will be a new universal docking node. It's meant to take the place of the current Pritchell module, which will then be undocked and deorbited. After that, Science and Power module and an airlock module will be docked to the new node. Then, in 2030, that entire stack, together with the Nauka module, will detach from the ISS and begin independent flight. The full ROS build-out is targeted for completion by 2034. There is, however, one catch in all of this. As chief designer Vladimir Solovyov openly admitted, Russia is heavily dependent on their American counterparts for the deployment of ROS on the ISS. And the Americans have already budgeted for extending the station's service life through 2032. So the 2030 undocking schedule looks optimistic, but far from set in stone. Well, those are the big changes underway at NASA, and we even touched on Roscosmos a bit. How would you rate these updates? Has NASA lost the plot, or does all of this deserve enormous credit, even if the timelines keep slipping? Let us know in the comments below. Let's talk about it. That's all from us for now. This was Rocket Hub Team. See you soon.